Hi, I'm Hatem Zain, founder and CEO of Ossia, based in Redmond, Washington. How many of you would like to have your phones charged automatically without taking them out of your pocket or bag? We need wireless power. For me, wireless means remote, automatic, effortless. But how do you safely and efficiently power multiple devices, and only those devices, at a distance? How do you find and follow the devices behind walls and around corners? And can you get all that FCC approved? It is my distinct pleasure to introduce you to Cota, a wireless power technology that addresses these challenges and more. For 6 years, we have been working on Cota, this amazing technology, developing it and patenting it, and currently it is in advanced stages of FCC certification. And now it makes its world debut right here on the stage of Disrupt. Cota is made up of a charger and a wireless power receiver. The charger would be the size of this box, while the receiver is small enough to fit inside your phone or even a AAA battery. Cota is the only wireless power technology that can deliver 1 watt of power at a 30-foot distance, enough to span an entire home, powering multiple devices. Cota is inherently safe as your Wi-Fi hub. A Cota-enabled device sends out a beacon signal that finds paths to the charger, which in turn returns the power signal through only those open paths back to the receiver, avoiding people or anything that absorbs its energy. Cota works without line of sight, powering devices behind walls and around corners without interfering with other electronic equipment. Like some of the greatest technologies of our time, Cota was discovered by accident. While experimenting with wireless signal management, I discovered it was possible to focus the signal such that it could power safely the receiving device itself. What you are about to see here today has been seen only by a select few. We hope you'll remember this moment. I have here with me a prototype of the Cota transmitter. This one has about 200 transmitters within it. Our current designs fit 3,000 transmitters into this device and about 20,000 transmitters into this 18-inch cube box. The more transmitters, the higher the efficiency. I have with me in my hand the wireless Cota prototype receiver. It basically guides the power from the transmitter to its location and only its location. So camera, please, yeah. The device uses the incoming energy to charge devices plugged into it. As you can see, the lights just came on. These lights are actually powered by the transmitter at this distance, about 7, 8 feet. So if I move it, the lights go off, the charger detects the change in location, finds the new signal, focuses it on the device, and powers the device at the new location automatically. The question is, can this charge a phone? So I have a phone here with me. Cota delivers about 1 watt of power, which is a third of a USB power signal from a USB socket, and within a 30-foot radius. And as you can see, the phone charges wirelessly. Thank you. Back to the slides, please. We have 4 core patents that have been issued by the US Patent Office and multiple patents internationally. Since Cota can charge a cell phone, it can charge many devices in a home. Remote controls, console game handles, Bluetooth headsets, MP3 players, flashlights, digital cameras, and the wireless keyboards, to name just a few. Just think, this could forever eliminate that annoying chirp from the mystery smoke detector with a dying battery at 3 in the morning. Cota will arrive in multiple forms to the consumer, built into phones and devices, built into standard batteries, and as dongles for devices that don't allow us to get to the battery. So we don't have to buy new devices to use it. Cota will be available by 2015 to the consumer, and we're currently in negotiations with electronics manufacturers to make this happen. While in the meantime, we're working with other industries, such as the oil and gas industry, which has forever sought wireless power to reduce the chance of disastrous sparking from all the wires powering their sensors. And that's just one example. Imagine the impact of Cota on medical, retail, and the hundreds of devices we call the Internet of Things. The possibilities are endless. We want to partner with electronics manufacturers to use our components, the technology, and designs to enable their products to be used to their maximum potential. And we're seeking more capital to bring the consumer technology to the market and enable new markets for this game-changing innovation. We want to unleash the imagination of anyone designing products that use power. Join us, and together we can make a world that's always on, always ready. Thank you.
All right, Cota. That was cool. Judges.
So I have a question. Is your strategy then to license your technology to the battery manufacturers or to actually manufacture the batteries themselves?
Yeah, great question. We're actually looking at multiple ways. There are companies that love to license. There are companies that want components. There are companies that want design. So we're supplying all three. So we're providing chip components to people who want to build it into their devices. For example, the battery manufacturers are not as adept at creating chip designs like the cell phone manufacturers. But if you go to the battery manufacturers, here's our patents, they'll say, we don't know how to do anything with this. While if you go to the cell phone manufacturers, they don't want to get another component to put in the phone. They'll say, I'll put your circuitry on my circuits and save space inside the phone. So that's the way we're going. So we're working with chip suppliers to be able to provide that components. We're providing our own designs for use by others, and we're providing also the patents just in case someone wants to patent them, wants to license the patents.
This is really exciting. I think Nicholas Tesla would be super excited about it. How much is it going to cost for me as a consumer to have this in my home?
Right. So the transmitter, the consumer transmitter, would be the size of the price of a Wi-Fi hub, basically. $100 or a little bit more. That's the way we're targeting the design. The size doesn't give you the idea of what's inside it. It's basically empty mostly. It just has to be big, that big. We cannot, at this moment, make it any smaller. So it's not a lot of components. It's basically just putting all that design. There's a lot of things inside this transmitter here. So just to give you an idea, there's hundreds of components. In our current design, there's about 500,000 components that go into it. So it's pretty expensive as a prototype. Yeah. But this will shrink down to that size because we can now put all the components together in one place. And integration reduces cost and size at the same time.
And when you moved, the signal stopped, is that right? And then when you stood still, it started charging again?
Yeah, thank you for noticing that. This transmitter is made for demonstration. So it shows you that there is a place where the power is delivered. It's not everywhere. Our final designs follow the device continuously, powering it as you walk around. So you will not see this disconnect. It will be constantly following the device. There's no delay.
And the receiver could be significantly smaller than it is now, or is that?
Yeah, this receiver has basically components that are all integratable into a single chip. There's nothing, it's just when you design an electronic circuit, you have to use off-the-shelf components. So the scale of this is all due to the off-the-shelf components. When we integrate into chips, everything drops down. This whole device would fit into that image of the dongle for the iPhone. Basically a sliver. We don't need coils, we don't need anything. It runs at the same frequency as Wi-Fi. So the people understand how Wi-Fi works and how far the signals go, and this is the same kind of thing. So you don't have to put that device in every room. You just put it in one room in your house, and it will power all your devices.
And you said the range was how far for one device?
30 feet.
30 feet.
Which is good for about a 2,500 square foot, two-story home in the US.
And is that line of sight, or if there are walls?
Non-line of sight. It will work behind walls. It uses the reflections and refractions. It's like your Wi-Fi signal. If you can get Wi-Fi signal, you will be able to get power.
What I want to ask about the business model. You said you're still working it out, but are you intending to sell these devices directly yourself, and the other components via original equipment manufacturers and directly as well, or?
Great question. We believe this technology should be in every device, not just our devices. So we want to enable others to build the technology. We've seen other companies interested to build the transmitter, and other companies interested to build the dongles or even build the receiver inside their phones. We're not planning to create our own inventory and supply chain management to sell the devices ourselves to the consumer. We want to sell through other manufacturers who have great devices. You know, I don't think anyone here would maybe want to give up their phone for the phone from us, but they will definitely would like their current manufacturer to provide our technology in their phone.
Along those lines, you presented examples on the enterprise side in addition to consumer, and I was wondering how you're thinking about pursuing or focusing on one of those two, and which one and why.
The vertical markets are all, we're being approached by companies who want to do the vertical markets. So we're not doing it directly with the users. We're doing it through companies who want to build that market utilizing our technology. But because, for example, the oil and gas industry doesn't care if they put this big thing in their office or not in their office, in the plant, it's too small an emitter for their system. So they don't need to be integrated. They'll use it. They have price flexibility on the cost. If it costs $200,000 and saves them $6 million in cabling, then it's a great buy.
Can the device, is there some sort of identification? Meaning if I come to your house, can I be stealing power from you?
So
or how do you make sure?
The system comes in and you can configure it only for your devices, or it's open for anyone. So you might go to a coffee shop, and anyone going to the coffee shop will have their phones charging because they want it to be like that. But the coffee shop may have their own critical systems that they run with with another unit that's linked only to their devices, so it doesn't share its power with incoming people. And this way you can have it closed or open, just like a Wi-Fi hub in a way. The beauty of it, if it's open, you don't have to open your phone and connect to the, to the network to power it. So to just find power and say, okay, I want power. If the network is open, you get power.
Very cool.
And if it's closed, how do you get it? What's the configuration?
Then you have to pair it like a Bluetooth or other devices.
Got it.
So I'm afraid we're out of time. Very cool, though. Thank you. That's Cota.